Hello, everyone. Welcome to Data Science with Python. This is the first class. So this class is an introductory level class for data science, lecture 1, session 1, the very basics. Six. So Python was invented in late 1980s as a teaching and scripting language. And there are some very good features about Python, simplicity, beauty, and convenience. Basically, this language is very intuitive, very easy to learn, to use, very easy to understand. And there is a very good feature of it is it has a large ecosystem of domain-specific tools, which means this is an open source language. Anyone can create a package and post it and share with everybody. So it has a very large ecosystem of packages and modules, etc. And in our class, we'll focus on these essential libraries or modules, as I said in the syllabus. Installation. We will use Python 3 point something version, okay? And I suggest you to install Python via the cross-platform Anaconda distribution. So this is a huge distribution. However, it has a lot of advantages because Anaconda comes with all of these libraries. So as long as you install Anaconda, all of these libraries will be installed at the same time and available for us to use. So you don't need to install these modules or packages one by yourself. And so I highly recommend you to install Anaconda directly. And it's available on any operation system. And to download Anaconda, click this link. Let's see link. It's a big, gigantic distribution, right? So it will take some time to install. If you haven't had it installed yet, please install it today, okay, right after the class. How to run Python code. So Python is interpreted rather than compiled. So this means we can program in an interactive way. We can type a line and then run it, and then type another line and then run it. Okay. And there are 4 primary ways to run Python code. We can use the Jupyter Notebook, Python interpreter, IPython interpreter, and some other things. In our class, we will only use Jupyter Notebook. And Jupyter Notebook is also built in Anaconda. So as long as you install Anaconda, it's available to you. It's somehow similar to RStudio because it allows us to put everything together. So it's a document format that allows executable code and text, graphics, and other interactive features. So it's a very convenient platform for us to use. It's easy to, it's perfect for teaching. I can show you my lecture notes. You can play with the code and get a result, and everything will be included in one document, just like in our when we use RStudio, R Markdown, we create a document which contains everything, right? So this one is also, okay? And it's reproducible, which means if I share my Jupyter Notebook with you and you run it, provided that we use the same random seed, we will get exactly the same result, okay? All right, let's move on. So let's start from the very beginning, Python syntax. We will use a chunk of code to explain the very basic components of Python programming. So this is a chunk of code, and meet point equals 5, and then define 2 lists, lower and upper. And then there is a for loop. And within the for loop, there is a if-else conditional. Okay? And then finally, print the two lists we created using the for loop. Okay, so let me run this. So you see lower has 5 numbers, upper has 5 numbers. So let's use this example to show the basic syntax in Python. So the script starts with a comment. So in Python, the comments also start with a pound sign. So anything on the line following the pound sign is ignored by the interpreter. So it's just for reading purpose. Right? And it won't be processed or executed. It will ignore it. So this is a standalone comment because it occupies an entire line, right? But you can also create inline comments. For example, we can type a pound key after a line of code. Okay, then again, because this is behind the pound key, it is ignored by the interpreter, right? So it's a pure comment. Right? Sometimes you might want to type multiple comments at the same time. So in Python, actually, there is no formal way to do it, but there is an informal way that is typing 3 quotes consecutively. Right? So for example, you can type 3 double quotes and type something, multiple lines of comments, and then end the comments with 3 double quotes. Right? So for example, if we do this, you see x equals 3. So the entire chunk of comments is ignored. Right? You can also use single quotes. Right? 3 single quotes. It will work too. No problem. And of course, in Python, each line terminates like just end of line terminates a statement. So you don't need to type semicolon or anything to end a statement. No. And sometimes you may have a very long line of code. You want to use multiple rows. So in that case, you can use a backslash. For example, s is equal to 1 plus 2 all the way to 8. You think this is too long. You want to wrap it to the next line. Just type a backslash. So it works. Okay. Alternatively, we can use parentheses. Okay, you see, if we use this, we can use parentheses to wrap their entire operation. Then we can get the same result. This one works too. Right? And usually the second option is recommended. Parentheses is preferred. Backslash is not, but you can still use it. And in the chunk of code, you see that we created 2 lists, empty lists at the same time. So these are 2 statements. In this case, you can use semicolon to separate them. So basically, it is similar to R. Okay, if you want to put 2 statements in the same line, use semicolon to separate them. So it's not recommended, but sometimes you want to put very short statements together. It's okay. You can do it. So this is equivalent to this bottom one, left to say. And then in the chunk of code, there is a for loop. Notice that there are indentations here. So it's different from R. In Python, white space matters. White space usually is used for indentation. So white space in front of a statement or a line means indentation. They are used to indicate blocks of code. So for example, in this case, we're using indentation to show that this if-else conditional is building this for loop. Right? So this is a chunk of a block of code, And also you see in the if-else conditional, some more indentations are shown here. Just notice that all the indentation, before indentation, there should be a column. You see indented code blocks are always preceded by a column on the previous line. So actually, this is automatic as long as you type this column and then you click return or enter, automatically indentation will be created for you. Right? This is an automatic behavior in Python. So whenever you type this, Python knows that you are going to create a code block, right? Below it. All right. Okay. However, white spaces within line does not matter. For example, the following three are exactly the same. So white spaces in front of a code statement matters. So they are indentations. But white space within lines does not matter. So these three are exactly the same. And then parentheses. Yeah, we are familiar with parentheses. There are two basic functionalities. One is to wrap or group statements or mathematical operations. For example, this one. And parentheses are also used to call functions. For example, in the print function, we can use parentheses to call this function. Print first value 1. Okay, this is very easy. We have seen this in every programming language. It's very common. And just pay attention that in Python, sometimes functions are called without any arguments. It may look weird, but it's acceptable in Python. For example, I create a list called L, and then I want to sort L. Then I call this dot method to sort elements in L, and then we get the result. Okay, so although there is nothing in the parentheses, it still works. And you still need the parentheses. Without the parentheses, it won't work. Okay. So this is a dot syntax. We will talk about it in a moment. So it's kind of very different from R. In R, we rarely use this dot syntax, but in Python, it's very common. Okay. So this is a summary. So in this small section, we talked about very basic syntax in Python. Any questions so far? All right. Let me move on. Let's move on to the second small session. Variables, objects, and operators. Because our class does not require any previous knowledge in Python, we have to start from very beginning. Okay. So very detailed and tedious things that we have to cover. So Python variables, how to assign or create Python variables? We can just use the equal sign. For example, x equals 4. And then, so this is assigning 4 to x. In many other programming languages, variables are containers or buckets into which you put data. So for example, in C, when you create a variable, integer variable, you should do this int x equals 4, which means you create a variable that is an integer variable. It's equal to 4. So you're essentially defining a memory bucket named X and putting the value 4 in it. So it's a bucket. It's somehow like you have a bucket which is called X, and you put 4 in it. So this is how it works in other programming languages. Right. And then, how about in Python? In Python, variables are pointers, not containers. And for example, if we create a new variable called X and assign 4 to it, you are essentially creating a pointer to an object or bucket containing the value 4. So it's something like this, somehow like this. Use that color, blue color. So there is an object, a bucket called 4. We create a new variable called X, and it's pointing to it. Okay, so this is a concept of variable in Python. A variable is a pointer to something, like to an object. Consequently, because of this nature, it's not necessary to define the data type when you create a variable because it's quite flexible. You can do the following. We first let X be an integer 1, and then we change our mind and let it be hello, a character string. Then we change our mind again and let it be a list of integers. Right? So they are all valid, although we change the data structure, and the type of data 3 times, okay? But it still works, no error message. So for example, if we run all of this, then the last assignment will be the ultimate one because it is the last one, okay? It overrides the previous ones. Okay? So it's somehow like this. You have an object 1, you have hello. I just use this to denote it. I don't have a pen. I don't have a pen that I can draw. So I just write it in a simple way. Sorry. Okay. So X originally was pointing to 1, and then you change your mind, and pointed to hello, and then change your mind again, lastly pointed to here. Okay. So this is a variable in Python. Right? It's a pointer. Right? So it's very flexible. You can change the data type and the shape, the structure, anytime you want. Okay? And the last assignment will be in effect. Sure. All right. Then in Python, everything is an object. So the variables are objects, functions are objects. And what is an object? An object is an entity that contains data along with 2 things, attributes and methods. So the object itself is a combination of value, attributes, and or method. So it's a comprehensive thing, item. It's not just a single value or something. It's kind of like a person has its features or characteristics. For example, if you create an integer variable X, which is equal to 4, so if you create a variable X, which is an integer, then what attributes it has? You can calculate, let me use a list. Suppose X is a list of numbers 1, 2, and 3. Then this is the value. 1, 2, 3 is the value of X. It's just one aspect, a small aspect, and it has its own attributes. For example, the length of it, okay, the data type of it. And methods are functions that you can apply to it. For example, you can calculate the mean of elements of it, you can calculate the median, standard deviation, etc. All of these are methods. Okay? So all of these are associated with the object, the value itself. Okay? Altogether is called an object. Okay? So that's why sometimes you may feel that the loops in Python are kind of slow still. Similar to R, it's kind of slow because it's object-oriented. Everything has its attributes and methods. It's very comprehensive. It's not like a pure, they are not pure values. All right. Attributes and methods are accessed using the dot syntax. For example, L is a list. The append is a valid function or method. You can append a value at the end of it. So now after we apply this, you have one more value, L. It will actually change L. And if X is 4.5, you can apply this isInteger function to check if it's an integer. Okay, so it's false. So this is a function that will return true or false values. But actually, you can also apply the type function and check the exactly data type. It's a float. It's a real number. It's not integer. Now let's move on to next topics. Operators. So in Python, there are these 5 groups of operators that we will use very often. See, arithmetic, assignment, comparison, actual S to change it, and Boolean, and then identity and membership operators. First group, arithmetic operators. So these are quite sort of familiar ones. There are 7 basic binary arithmetic operators. So we're talking about these 7, okay? Plus, minus, multiplication, division, floor division, modulus, and exponentiation. Okay. So these are, all of them are quite familiar except for this floor division. Just pay attention to this. So this one will return the quotient of A and B round down to an integer. Always round down, round to a smaller value, even for negative numbers. And this is A to the D. In R, I think we use this, right? I think so. I'm confused somehow sometimes. Yeah, but in Python, we use this double asterisk sign. And there are 2 unary operators, negation and plus. So we rarely use them. Negation means make it the opposite, or opposite value. And the last one is a matrix product. We rarely use this either, but it's available. There are actually many matrix operators in Python as well. So let's see one example of this floor division. -10 divided by 3. The floor division is equal to what? If we just use regular division, it will be -3.3333, right? Infinitely many threes. If we round it down, will we get -3 or -4? It's -4, right? So it's very literal. you will round the result down to an integer. So negative 3.333 down to negative 4. Okay. So in your kind of intuition, you might want to round it to negative 3, but actually it should be negative 4. Okay. Okay. Assignment operators, we have seen this already. Just use the equal sign to assign a value to a variable. So this is the way we create a new variable. We can also, after we create it, we can also add an integer value to it and get the result immediately. And this kind of operation is very common, kind of like we try to update the value of a variable. Right? For example, in a for loop, we might want to keep changing the value of a variable. Right? So for example, a is equal to a plus 2. This means we add 2 to a and update the value of a. Because this is so common in Python, there is a special operator. Right? It's called built-in update operator. So for plus, it's like this. So a plus equal 2 is equivalent to a is equal to a plus 2. Okay? If you run it, you get the same thing. Okay? And actually, we have similar update operators for subtraction, multiplication, division. Okay? So for example, this means a is equal to a times b. This means a is equal to a divided by b. So they are quite common in Python. They are available for us. Next group is comparison operators. Equal, not equal, less than, greater than, less than, equal to, greater than, equal to. So these operators will return a true or false value, logical value. Just pay attention to the first one, equal. You need to use 2 equal signs to indicate this is a comparison operator, not assignment operator. So this is a common error for beginners in Python. Sometimes you want to do a comparison, but you use a single equal sign, equal operator. That means assignment, not comparison. Right? And not equal is denoted in this way, exclamation mark plus equal. Right? So it's kind of special in Python too. And the comparison operators can be combined with other operators to do something. Okay, for example, if you want, you can check if a number is odd or not by calculating the modulus and compare it with 1. If the modulus is equal to 1, that means it's odd. Otherwise, it's even, if it's an integer. Modulus yields the remainder of a division operation. So for example, 25 modulus 2 is equal to 1. The remainder is 1, which is equal to 1. So this will yield a true, right? This means 25 is an odd number. And for 66, you'll get false, right? So you can combine arithmetic and bitwise operators to do some check. And yeah, you can also string together multiple comparisons together. So this is kind of special. You see, you can actually check if A is between 15 and 30 in this way. So this is allowed in Python, but I don't think it's allowed in R. You see true. So only if A is indeed in between 15 and 30, so it will check these 2 conditions at the same time. If both are true, you get true. So that is essentially the same with the next line. A is greater than 15 and A is less than 30. Okay. But usually we will break the conditions in this way. It will be more clear, more obvious, and easier to understand, actually. So I recommend you to use this kind of expression instead of this. Okay. All right. Bottom line is you can actually combine this kind of comparisons together. All right. Next group of operators are Boolean operators. So these operators are used to combine logical values together or comparison statements together. So there are 3 of them, and or not. For example, x is equal to 4, x is less than 6, and x is greater than 2. Okay. We get true. So and will yield a true only if both are true. True and true will yield a true. Right? Other cases will always yield a false. So true and false will yield false. False and true will yield false. False and false will yield false. So it's quite strict. Right? So this is and. Or if one of them is true, then you get true. So x is greater than 10, this will yield a false. X modulus 2 is equal to 0. So 4 divided by 2, the remainder is 0. So this will yield a true. So false or true, the result should be true. Okay? So or is much easier. True or false. False or true. True or true. All of these 3 cases will yield true. And lastly, not. Not is negation. It will flip the result to the opposite. So for example, x is greater than 6. This will yield a false. Then not false will be true. Okay. So these are called Boolean operators. They are used to connect or combine comparisons and yield a single true or false value. Last group is identity and membership operators. There are 2 small groups, identity operators. And so these 2 are identity, is and is not. And then the last 2 are membership operators. Okay. So see, is means A is B. This will yield true if A and B are identical objects. They are exactly the same. Values, features, everything is the same. Right? And A is not B is true if they are not identical. A in B is true if A is a member of B. Not in B is true if A is not a member of B. Let's see some examples. So first, identity operators is and is not. Let's see. So A is equal to 1 to 3, B is equal to 1 to 3. If we check if A is equal to B or not, this is a comparison operator. A comparison, okay? This is not identity. So we will get true. Okay. So how about identity? Well, we want to check if A is B or not. We get false. So it's kind of weird. They are apparently equal. Why they are not identical? So that is because they are pointing to 2 different objects, which are the same in values, but they are still 2 different objects, 2 identical, two equal objects. Right? Somehow like this. Right? You have a list here, 1, 2, 3, and also another list 1, 2, 3 here. Right? So A is pointing to this, and B is pointing to this. So they are pointing 2 different objects. So that's why they are not identical. although the two objects are equal somehow in terms of values, but they are still not identical. So then you might wonder when they can be determined to be identical. The next example, A is equal to 1, 2, 3, and B is equal to A. Then if you check if A is equal to B or not, is that true? So in this case, it's somehow like this. You have a list 1, 2, 3, and A is pointing to it. Okay, A is pointing to it. And then B is equal to A, which means B is pointing to A. And essentially, it will be pointed to the list. So that's why A and B are pointing to the same object. So then in this case, they are identical. They are exactly pointing to the same object. All right, let's move on. Last one, membership. So this is also a little bit tricky. It is used to check if one object is a member of another object. So the first example, 1 is in 1, 2, 3 or not. Apparently it is yes, right, true. So how about this? 2 is not in 1, 2, 3. 2 apparently is in it, so it will give you false, which makes sense too. How about this? 0, 1 is in 1, 2, 3 or not? The result is false. So apparently it will only give you a single logical value, true or false. It will check exactly if this 0, 1, this list is in the second list or not. Right? 0, 1 is apparently not a component of 1, 2, 3. Right? How about this? 1, 2 in 1, 2, 3. It looks like 1, 2 is part of 1, 2, 3. However, if you check it, you get false. Okay? Because 1, 2 is not a member of 1, 2, 3. Okay? Although they overlap somehow. So when they will, you will get a true, only in this case. If 1, 2 is literally a member of the second list, right? 1, 2 isn't it, right? In this case, we got true. Just pay attention. This is different from the membership operator in R. In R, the result, the number of logical values you get using this membership operator depends on the dimension of the first object. For example, if the first object has two elements, then you will have a vector of 2 true or false values. It will check each element in the first object and see if it is in the second object or not. So that is in R, but in Python it's different. Okay, you only get one single logical value, okay? And it will be very strict. It will check if the first object is exactly a member of the second object. So no compromise. It will not focus on one element, a single element in the first object. All right, so that's all for session 1.2. So these are variables, objects, and operators. So after this session, you'll be able to read some simple code about math operations or comparison, logical comparisons. Right? All right. Then let's move on to session 3, building data structures. We have about 15 minutes. Hopefully we can finish this part. Yeah. So we're talking about compound types, which means elements in these data structures can be of different data types. They are compound types. There are 4 types: list, tuple, dictionary, and set. There is one example for each type. List will use square brackets to wrap elements and separate the elements by comma. So these are used to create mutable ordered collections of values. Mutable means changeable. You can change the number of elements and the contents of a list. And ordered means the values are ordered so that you can use position to subset or to extract specific elements because they have their orders, right? Or indexes. Okay. And then tuple. Tuple, this is an example what use regular processes to wrap elements. So they are immutable ordered collections. Immutable means once you created a tuple, you cannot change the structure and the contents of a tuple anymore. It's basically fixed. And third one is dictionary. So these are unordered p-value mappings or pairs. We use curly braces to wrap them. P-value. Use column to connect the p and the value. And last one is set. Also use curly braces, but they are unordered collection of unique values. It will not accept repetitions in the values. So let's take a look at them one by one. So lists are ordered and mutable data collections. For example, so this is a list of first several prime numbers. This is L. We use square brackets. So lists have a number of useful properties and methods available to them. So as I said, as we just learned, objects in Python have its own attributes and methods. For lists, it has some properties or methods. You can check the length of it for elements in it. The len is used to measure the length. By the way, lists are one-dimensional objects. So that's why it makes sense to check the length. And as we have learned before, we can use a append attribute method to add an element or a value at the end of the list. And it will actually change L. Right? You can also concatenate a list to the end. For example, L has 4 prime numbers, now 5 now. Okay, we add 11 to it. Okay. If you want to add some more, we can just concatenate with a different one. However, pay attention that this operation will not change L. The append method will change L itself. It will actually add a value. But this concatenate using the plus operator will not change L. So let me add a cell and let's check what L is equal to. So see, L is still like this. It still only has 5 elements, even after we concatenate these 2 numbers. After that, okay? And then another method that we can apply to a list is the sort method. Sort will sort the elements of a list and it will change the list. Okay, you see originally L is like this, now L is ordered. Again, this is different from R. In R, when you sort an object, then in the printout, you will see it is sorted, but it itself is not changed actually. If you type it again, you got the original one, unless you save it, you save the result and give a name. or keep the same name. Otherwise, it will not be changed. But in Python, this method usually will change the object itself. Okay. All right. So lists are very flexible in a sense that although it is one-dimensional, elements in a list can be of different data types, can be of different data structures. So for example, I can create a list like this, 1, 2, 3.14, and a list, right? The first one is integer and then a character string, then a float number, then a list of integers. Okay? So this is completely acceptable, completely fine. Just if this is the case, if we create a list in this way, then you'd better not start it. Okay? You will get trouble. If we sort it, you will get error message because Python does not know how to order a string and numbers. So you cannot order them. All right. For lists, you can extract single elements or multiple elements from a list using the position. Just pay attention, Python uses zero-based indexing, which means the index of the first element is 0. It's not 1. In R is always 1, right? So for example, if we want to extract the first element in L, we should use L brackets 0. Yeah, similar to R, we use square brackets to subset objects. Right? But just pay attention, 0 is the index for the first element. Right? And the second element has index 1. It's a little bit strange at the beginning, but later on you will be you will feel more comfortable with it. Okay. So this is L. And Python also has negative indexes. -1 represents the last element of a list. So for example, you want to extract the last one, you can say L brackets 1, -1. And -5 will be 1, 2, 3, 4, 5 will be the first element, which is 2. All right. And the next chunk of code, because this is from one of the textbooks, shows you the index system, right? How the positive indexes and negative indexes are defined. So 0, 1, 2, 3, 4, 5, -1, -2, -3. So if you want to index or extract a single element, specify the index that is to the left of the element. For example, 2. The positive index is 0. The regular index is 0 because 0 is to the left of it. Okay, and 11, the positive index is 4. The negative index is -1. Both of them are to the left of the elements. So this is how the indexes are defined in Python for your reference. And it's also possible to slice data. Slice means extracting multiple elements at the same time. For example, you can use this column notation, which means I want to extract 0 to 3. But pay attention, in Python, by default, the last index is not included. Okay, 0 colon 3 will be L0 to L2, not including 3. Right. If you compare it with this one, 0 to 3 are the 3 numbers in between 0 and 3, okay? Not including 7. 7 is outside of the range. You can also leave out the first index. If you will start from the very beginning, you can just type column 3, omit 0, get the same result. All right. Next, tuples. Tuples are ordered and immutable data collection. So immutable means once you define it, you cannot change it anymore. So for example, T is a tuple with 3 numbers, 1, 2, 3. And actually, you can omit the parentheses. You can just do this. T is equal to 1, 2, 3. Right? So this will work as well. But usually, I recommend you to use braces and parentheses there. And one important feature is tuples are not mutable. By the way, you can check the length of it because tuples are also one-dimensional. You can check the length of it. And you can index it, extract single numbers from it. Again, zero-based index for that. Okay. But you cannot change it. Okay. Remember, T is 1, 2, 3. So the second element, T1, should be 2. Right? If you want to change the value of the second element from 2 to 4, let's see what happens. You get a type error. A tuple object does not support item assignment. So once you create a tuple, you cannot assign new values to elements of it. You cannot change values anymore. Right? Similarly, you cannot add more values to it. Suppose we want to append 4 to it. You see attribute error. Tuple object has no attribute append. Again, go back to what we have learned and emphasize it. In Python, all the objects have values and associated attributes and methods. Right? So apparently, T was created as a tuple. Consequently, T does not have this append attribute or method. So that's why you cannot use it on T at all. Right? So this is very intuitive. And later on, you will be more used to it. Right? Used to it. So you cannot change tuples. And the indexing and slicing are similar with lists. The only difference is it cannot be changed. Okay. All right. That's all for today. Tomorrow, we will continue to talk about Python basics.